Hello everyone. Now we will learn the basic knowledge of boiler powerizing systems and equipment. This section knowledge points are as follows. First, boiler powerizing systems and their classifications. Second, coal feeders. Third, the function of coal mears and types. Fourth, cyclone separators. Fifth, weir-type coal feeders. The coal powerizing system refers to the combination of equipment, related connecting pipes, and accessories required to ground raw coal into powder and then transport it into the boiler furnace for suspension combustion. It is commonly referred to as the powerizing system. The powerizing system can be divided into direct-fired and intermediate beam storage types. The direct-fired powerizing system refers to the coal powder being ground into powder by the coal mear and then directly blown into the furnace for combustion. The intermediate beam storage powerizing system involves storing the ground coal powder in a coal powder bin first, and then, according to the boiler's operating load requirements, outputting the coal powder from the coal powder bin through a coal feeder and sending it into the furnace for combustion. This is the setup and process flow of the intermediate bin storage and direct-fired powerizing systems. The function of the coal feeder is to adjust the coal feeder rate according to the needs of the coal mear or the boiler load, and to continuously and evenly feed the raw coal into the coal mear. Coal feeders come in various types, such as disc type, vibrating type, scraper type, and belt type. Here is an introduction to the beltway feed coal feeder. This type of coal feeder is primarily composed of a body, a coal feed bell mechanism, a weighing mechanism, a trail-type cleaning scraper, coal breakage, and clogging signal device, a cleaning and conveying device, an electronic control cabinet, and a power supply and motor cabinet. It typically operates under positive pressure and employs a fully enclosed design. The working principle is that raw coal is fed into the coal mear via the coal feeder belt mechanism. The weighing mechanism is located between the coal inlet and outlet of the coal feeder, and consists of 3 weighing idlers, a pair of load cells, and electronic components. The control system of this coal feeder operates under the command of the Unit Coordinated Control System. It adjusts the speed of the driver motor based on the coal feeder rate signal required by the boiler load, ensuring that the actual coal feeder rate matches the required coal feeder rate. Below the weighing mechanism, there is a tray-type cleaning scraper mechanism that sweeps the coal to the outlet for discharge, clearing the accumulated coal. The weighing mechanism above the coal feed belt. There is a coal breakage signal device. When there is no coal on the belt, it triggers the vibrator of the local bunker. Additionally, there is a coal clogging signal device installed at the outlet of the coal feeder. If the coal flow is obstructed, it stops the operation of the coal feeder. The coal mear is the primary equipment in the powerizing system. Its function is to ground raw coal into coal powder and dry it to a certain extent. The principle of coal grounding in coal mears mainly involves impact, extrusion, and grinding. Based on the operating speed of the cold grinding components, cold mills used in power plants can be roughly categorized into the following three types: low-speed cold mills, rotational speed of 16 to 25 revolutions per minute; medium-speed cold mills, rotational speed of 50 to 300 revolutions per minute; higher speed cold mills, rotational speed of 500 to 1,500 revolutions per minute. In China's coal-fired power plants, the widely used types of coal mills are the cylindrical bore coal mills and the medium-speed coal mills. The double inlet, double outlet bore coal mill features a cylinder equipped with manganese steel armor. The cylinder is driven by an electric motor through a reduction gear to rotate at a low speed. Coal flows from the outlet of the coal feeder into the mix box, where it is pre-dried by bypass hot air before jumping into the hot shaft. The rotating screw conveyor then sends the coal into the coal mill, where it is ground by steel boards. Hot primary air enters the cylinder through the central tube of the hollow shaft. The hot air inside the cylinder serves both as a coal powder dryer and a coal powder carrier. After completing the drying of the coal, it exits the cylinder in the opposite direction of the coal's entry, carrying the coal powder out of the mill through the annular passage between the central tube and the hollow shaft. The coal powder and air mixture then mixed with the bypass air from the mixing box and enters the up coal powder separator. The coarse coal powder, separated by the separator, falls back through the return powder pipe to the entrance of the hollow shaft, where it mixes with the raw coal and re-enters the coal mill for further grinding. The gas power mixture exiting the separator is used as primary air and sent to the furnace, or enters the fire powder separator for gas powder separation. Now, let's understand the medium-speed coal mill. The grinding components of the medium-speed coal mill vary, but they all share the same working principle and a similar basic structure. The coal mill can be divided into four parts, from bottom to top: the driver unit, the grinding components, the drying and separation space, and the coal powder separation and distribution device. The working process involves the electric motor driving the vertical mill shaft through a reduction gear, which in turn drives the grinding disc or grinding ring to rotate. Raw coal enters through the coal chute and falls onto the surface of two sets of composing grinding components, such as the grinding disc and rollers, where it is crushed into coal powder under the action of compressive force. The ground coal powder rotates with the grinding components and is thrown to the top of the air ring due to centrifugal force and the continuous pushing of the coal and coal powder being ground. Hot air, drying agent, enters the annular drying space at a center speed after being rectified by the air ring, equipped with flow equalizing guide vanes, drying the coal powder and carry it into the coal powder separator at the top of the coal mill. In the separator, the unqualified coarse coal powder is separated and returned to the ground air through the bottom of the chemical separator for regrinding. The qualified coal powder is carried out of the mill by the drying agent through the coal powder distributor. It enters the primary air pipe, where it is directly fed into the furnace through the burner for combustion. The coal-board materials that are difficult to grind, such as coal gang and stones, fall through the air ring into the debris box and are periodically discharged. The material discharged from the debris box is referred to as stored coal. Now, let's get to know the cycloseparator. The dust-laden air enters the cyclo element tangentially. Inside the cyclo tube, the gas forces a swirling flow. The strong centrifugal force causes the solid particles and gas particles in the air to be thrown off and accumulate on the inner wall of the cyclo tube, eventually falling into the ash hopper. The clean air continues to rise into the exhaust chamber and flows out through the exhaust port, following the cycloseparator. Now, let's understand the structure and working conditions of the rotor coal feeder.
The structure and operational conditions of the impeller feeder. The impeller feeder is a primary auxiliary device. In a coal-fired power plant's conventional bin-type pulverized coal system, serving as the main equipment to supply fuel to the boiler. The impeller feeder is primarily composed of the following components: upper body, lower body, turbine box, drive mechanism. The upper body is a cast iron piece with a wider top and narrower bottom. It contains a horizontal screw shaft with right-hand and left-hand threads at both ends, which operates two sliding plates to control the opening and closing for pulverized coal feeding. The lower body houses scraper plates, a bow-shaped impeller, and a measuring impeller. Beneath the lower body is the drive mechanism, which is connected to the turbine box.
Classmates, in this section, we have learned about the boiler power rising system and its classification, the law and types of coal feeders and coal mills, the cycloseparator, the rotor coal feeder, and other related content. These pieces of knowledge are crucial for the safe operation of the boiler. Today, we have reached the end of our introduction to the boiler power rising system and equipment. Thank you all.